an excellent instrument that can provide accurate information on various high-impact weather phenomena around the airport. I'm not going to talk about technical details of weather radar. Professor Marciano already gave an excellent introduction to the instrument, but instead I'm going to highlight a couple of benefits that modern weather radar has in comparison to conventional weather measurement instruments, for example surface weather stations. Well, first of all, weather radar has high resolution and a large coverage. So the coverage can be typically up to 250 kilometers in range, and the resolution can vary from a few hundreds of meters to a few kilometers. And thanks to this high resolution and large coverage, radar can be efficiently used to monitor phenomena with different scales. So with radar we can monitor large-scale frontal systems, or we can locate individual small-scale thunderstorms. The radar provides also very fast measurement cycles, so with the radars we can generate new radar images every few minutes, and this is important especially when we are monitoring fastly evolving phenomena such as local thunderstorms or wind shear events. And most importantly, weather radar enables the detection of not only detection of rainfall patterns or locations of individual thunderstorms, but we can actually identify different phenomena that are associated with these phenomena, for example hail, shear and many other phenomena. So the radar is a very versatile instrument. As you know, severe convective weather is one of the major concerns from the viewpoint of aviation activities, and individual convective storms, they are usually very local, very rapidly evolving and short-lived phenomena. So we are talking about the spatial extent of a few kilometers only and the life cycle of a few tens of minutes only. Despite the short life cycle and the local area of influence, individual convective storms, they may have severe consequences at the ground level and at the air. And weather radar is an instrument that can locate the storms with the required resolution and capture their life cycle despite the short lifetime of the storms, and also reveal several characteristics of the storms. As an example, with the weather radar we can not only identify the weather close to ground level, but also by changing the elevation angle of the antenna we can actually capture the full three-dimensional structure of the atmosphere. So this allows us, for example, to analyze the vertical structure of the precipitation of storms. As you can see here on the right hand side, we have an example of the vertical cross-section from an intense thunderstorm. And you know that the altitude of the storm, or the vertical extent of the storm, is also related to the general intensity of the storm. So this way we can also identify where the most intense thunderstorms are, and we can, for example, guide the aircraft to avoid certain areas or choose the right flight level according to the vertical structure seen in weather radar data. Modern dual polarization technology nowadays allows the classification of precipitation types, so we can not only see where is it raining and where the weather patterns are, but we can also see, for example, if the storms are producing hail, which is very important application from the viewpoint of aviation. So here on the left hand side we have an example of VAISALA hydroclass precipitation type classification algorithm, and we can see that there is a storm producing some hail, and such storms of course should be avoided by the aircraft. And of course weather radar can be applied to identify wind shear, and this is based on the Doppler information provided by weather radar. So as you know, weather radar provides also information about the direction of the movement of the precipitation, and this information can be applied to derive different wind shear related products. We can identify, for example, the areas of large wind shear lines as illustrated, for example, in the image here on the right hand side. So the black line shows the wind shear line identified from weather radar information. And we can also identify small and localized shear phenomena such as microbursts and downbursts, which are problematic from the viewpoint of aviation activities. So this was about the weather radar in general and its applications in aviation. But the radar information, it's important to note that the radar information is useless if we do not have proper tools to analyze the information and proper tools for end users that allow them to interface with the information in such a way that actually provides added value to their decision-making process. And this is where the role of weather radar software becomes very important. So at VAISALA we have this VAISALA Iris weather radar software, and this software has existed already for quite a long time. So the first versions of Iris were introduced already in 1990s, and gradually over time we have naturally developed the software further. And the latest version of Iris weather radar software, Iris Focus, was launched in 2015. And in the following I'm going to tell a little bit more about this modern next generation weather radar software. So when we started to develop Iris Focus software, we thought about some key features that the software should have. One of the features that had probably the highest priority was the accessibility. So we wanted to make a software that can be accessed from wherever the data is needed. So the software should not need any installation of the weather radar software on the computer where the software is used. And this is why we created the software to use this web-based approach. So the weather radar software can be used from a standard web browser, for example, Internet Explorer or Mozilla Firefox or any other standard browser. We also wanted to put effort in the interface, so we wanted to make a simple and easy to understand interface. So when the user sits in front of the software, it doesn't require an extensive training to cover all the features the software has. And since we wanted to go with the web-based approach, we also paid a lot of attention to the safety and security issues, and the software has been tested by a third-party company specialized on these safety and security aspects. So we are following the latest information security standards with this software. Despite the web-based approach and the easily understandable interface, we wanted to make no compromises with the data and products that are available on the software. So all the products and the features that are available in conventional weather radar software are available also in Iris Focus. So for example, and actually in Iris Focus we have much more new features when you compare to the conventional weather radar software. So for example, in the background of the software we use this geo server that enables, for example, when the user zooms in, we can regenerate the data with higher resolution, and we can also not only regenerate the data but also the background maps and get more detailed maps when you have a close view of the area of your interest. There are a number of interactive features in the software, so the user can adjust the constant altitude PPI altitudes on demand in the web interface, do some smoothing, set the transparency of the layers, or visualize several products simultaneously on the web-based interface. Here is an example of one of the features, the new features that we have in our weather radar software. in conventional weather radar software, the users usually can do cross-sections only along straight lines. But in Iris Focus, the user can do the cross-sections not only along the straight line, but also along any line the user wants. So we can do, for example, cross-sections along the approach path of the aircraft, which is an important aspect from the viewpoint of aviation. The user can also get automatic alerts for significant weather. The warning areas can be configured interactively in the software, and also the alerts or the criteria that trigger the alerts can be configured in the software. And if you're interested in trying the software on your own, you can go to the website iris.vaisala.com and get your personal account and test the software using our real-time data from our research and development radar located in Helsinki. So you can try the software on your own and start using it today if you want. So I'm now moving into the final part of my presentation, which is about radar software as a sensor management system, and more specifically how we can use weather radar software, VAISALA weather radar software, to integrate data from several instruments together. This multi-instrument integration is a great way to improve the value of weather information. And of course, when we are talking about the integration of weather radar information, we are talking about integration of data from multiple radars. And in Iris we have capability to integrate radar data from several radars, including VAISALA weather radars, but also non-VAISALA weather radars. And the radar type can be, it's not limited to the radar type, so at VAISALA we are the manufacturer of C-band weather radars, but in Iris we can integrate also data from X-band weather radar, S-band weather radar, and C-band weather radar, as far as we get it in a common standardized radar data format. Sometimes it's also useful to integrate not only radar data, but data from other instruments. And we can integrate also data from LiDAR, lightning, and satellite, for example. And the benefits of such integration are obvious. So, of course, when the data from several instruments are integrated, they can be conveniently displayed in the same software, so the user can access easily all the data related to each other. We can also coverage can be extended by combining, for example, several radars in the form of radar composites. We can improve the quality of data in the areas, for example, where two radars are overlapping. So if one radar is experiencing some problems, the other radar can back up the other radar. And of course, when we are integrating data from different types of instruments, such as LiDAR and weather radar, we can actually enhance the detection of phenomena in different weather conditions. Here is an example of multi-instrument integration using VAISALA Iris Focus software, and we have actually added here a layer of lightning data in the software. And the benefits of this kind of integration include, for example, extending the coverage beyond the observation coverage beyond the radar coverage. So the user can see the storms even before the storm approaches the radar coverage, and this way can extend the overall observation coverage. And when the storm moves into the radar coverage area, we can get more detailed information about the characteristics of the storms, because we have two overlapping independent information sources on the same screen. Here is another example of multi-instrument integration. So this is a case example from Palermo Airport, where we are deploying a LiDAR and radar sensor information together with our local partner Euroelectronica. And the overall aim at the Palermo Airport is to provide better wind and wind shear observations. And here is an example of aerial image of Palermo Airport, and as you can see, the airport, it's very close to the sea, and the airport sits between the sea and relatively high mountain. And you can imagine that this quite challenging and complex environment, it can create all sorts of interesting mesoscale wind shear effects, which makes it very challenging from the viewpoint of wind shear observations. And the solution that we are providing at the Palermo Airport is an LDES expand radar, so a non-VAISALA weather radar, combined with the Leosphere LiDAR. And this is integrated through VAISALA Iris weather radar software and also made available in VAISALA Avimet low-level wind shear alert software. Here is also a general design of the solution that we are providing at the Palermo Airport. So we have the radar information, providing radar information, and this is providing, for example, wind shear information in the case of wind shear embedded in precipitation. And then we have the Leosphere LiDAR that is providing wind shear alerts in the clear air conditions. And when we combine these two instruments, we can actually enhance the overall detection capability of wind shear in different kind of weather conditions. And this information is integrated in centralized solution at the Iris weather radar software. And the wind shear warnings there, they are made available over network connection to different end users with Iris Focus software. Okay, now moving into the conclusions of my presentation. So it's important to remember that the radar data itself is not enough. It's important to have proper tools that allow the users to interface with the information such that it provides added value to their decision making. The availability of automatic algorithms and tools for accurate detection of different phenomena associated with thunderstorms, for example hail, enhance the overall capability of convective storm analysis. And when we are integrating data from several instruments, for example lightning data, and overlaying with radar information, we can enhance the understanding of the severity of the storms. And the case example from Palermo Airport demonstrates that integrating radar and lighting information can provide significant added value to the decision-making process of wind shear alerts. So that's all, thank you.